Hello and welcome to the Titus Timeout podcast. I'm Jenny Abney-Civy, and this week I'm going to discuss how an ERV works. An ERV, or Energy Recovery Ventilator, recovers the energy in the exhaust air of the building to use to preheat incoming ventilation air. It also allows you to take heat out of warm outside air before it enters a building. So we'll look at how that works. One quick thing to note is that there are ERVs and HRVs. HRV stands for Heat Recovery Ventilator. The difference is that the HRV only recovers heat, where the ERV recovers heat and humidity. ERVs are sometimes called enthalpy recovery ventilators for this reason. I'm going to talk about ERVs, but the basic heat transfer concept is the same. There are different types of ERVs. Some use rotating enthalpy wheels and some use a fixed plate. The enthalpy wheel rotates between the supply air and return air side of the unit, transfer the energy between the two sides. And the fixed plate type passes air through in two different directions, transferring energy between the two air streams. So in one direction, the air can only pass one way, and in the other direction it can only pass through the other way. So the air streams aren't colliding on the inside. They both use media that transfers heat and a desiccant that transfers moisture. So let's draw an ERV. I'm more familiar with the air-to-air wheel ERVs, so that's what I'm going to draw. So this is our casing, and we'll put a wheel in here. You're kind of looking at it from the side, but let's say it rotates this way, kind of towards us at the top. And now we need to separate the return side and the supply side. So outside air will come into the bottom of the unit here, pass through the energy recovery wheel, through a fan and out into the supply air system. The return air will be ducted back here. It passes through the wheel, and there's another fan over here that'll exhaust the air. Now this may not be exactly how it looks. You may have your fans as part of an air handler somewhere else, but this is the general idea. So let's look at summer operation first. So in the summer, the outside air is warm and humid. Let's say it's 95 degrees and 115 grains per pound of dry air. This air enters the unit and goes through the energy recovery wheel. The wheel adsorbs water and transfers heat. Adsorption is the adhesion of water molecules to the solid in the wheel. The air on the other side of the wheel is now cooler and drier, so maybe it's 80 degrees and 75 grains per pound. So from the beginning of the unit through the wheel to the end of the unit, you got 15 degrees of free cooling, plus you reduced your humidity of the air coming into your space. Now the supply air can go off and be cooled down, but you don't have to cool from 95 to 55, you cool from 80 to 55, so you're using less energy to cool your air. Okay, now the return air comes back from the space, say at 75 degrees and 65 grain per pound. Kind of like this new purple. You're probably going to see more of this color. So it passes through the wheel, which is rotating. The heat and moisture that was picked up on the supply side is now rotated into the return air stream, and the return air picks this up and exhausts it out of the building. Maybe this air is 85 degrees and 100 grains per pound. So this heat and humidity is now exhausted back outside without ever getting into the system. Okay, so let's move this out of the way and let's look at winter operation. Let's draw our unit again. Our casing, our energy recovery wheel here. We'll separate our supply and return side. Put a fan here, and then put a fan up here. Let's draw in our outside air, supply, return, and exhaust again. Okay, in the winter, the outside air is cool and dry, but the inside air is warm and humid. So the outside air picks up heat and humidity from the wheel that is left there by the return air. So it'll look like this. So say the outside air comes in at 20 degrees and 10 grains per pound. It goes through the wheel. The wheel has picked up warm return air as it rotates down. Now this cold air is going to pick up this warm, humid air and warm up and go into the space at, say, 60 degrees and 35 grains per pound. Now, it may still have to go through a heating coil, but so instead of heating up from 20 degrees, you're heating up from 60 degrees. Or maybe 60 degrees is enough to supply your space. Your return air is coming in at, say, 75 degrees and 40 grains per pound, goes through your heel, deposits its heat and humidity, and comes out the exhaust at, say, 30 degrees and 20 grains per pound. So from the outside air to the supply air, you got 40 degrees of free heating and you increased your humidity. And then on the return side, you gave up heat and humidity to the wheel to help warm up the air on the supply side. So this is heat you would have normally just exhausted outside, so it's like free heating. So let's bring everything else back on screen. So ERVs save energy by keeping heat and humidity out of the building in the summer and recovering the heat and humidity in the winter to use as heating. So that's how ERVs work. Don't forget to subscribe to our YouTube channel, and thanks for taking the time out with us.